Hi there, guys. This is 15G. This is confidence intervals. So up until now, we've been testing whether or not a sample is similar to the original population that it's taken from. And in general, we know something about that population. If we don't know that the population has a particular standard deviation, then we can estimate it. But we always know what the mean is from that original population. Now, sometimes it's the other way around. Sometimes you're taking a sample in order to get an estimate for the mean from the population. Now, your best unbiased estimate for the mean is going to be the same as the sample mean. But if you're talking about the sample likely coming from a normal distribution, then you can make a confidence interval in which the mean should lie. You could say, I'm 95% sure that the mean lies between this value and this value based on my sample. So that's what the confidence interval is about. It's about making predictions for the mean of the population based on the sample mean. Okay, so in other courses, this can be done in quite a bit of detail. And normally it's done to start off with the Z distribution, where the original population standard deviation is known, which is a really odd thing because that's the easier thing to do. But why is it that you would know the standard deviation and not the mean of the original population? So the IB, or at least with this course, has decided actually it's more likely that you'd need to do this with a t-test or t distribution rather than a z distribution. So we're going to go straight to doing this on a calculator. And on a calculator, you can't do an inverse t-distribution, so we're just going to do the confidence interval straight away on the calculator, in fact. So this is actually really short. So let's have a look at the example. So example 8, the sample below is taken from a population which can be modeled by a normal distribution. Find a 95% confidence interval for the population mean. Okay, so if we were looking for the population standard deviation, we'd need to work out the standard deviation of this, and we'd need to do Bessel's correction again, times the variance by n over n minus 1, or actually just take it from your statistics on your calculator, but we don't need to do that in this case. Okay, so what do? So we go straight to our calculator, and we type into Sheets these numbers in one column. And then after that, you go statistics. And in statistics, the third of your options is confidence intervals. Now, this is going to be a t interval because we don't know what the standard deviation of the population is. We only have this sample to go by. So it's going to be a t interval. I'm going to click on that. And the method which I'm going to use for this one is a data method. Obviously, it could also be done like in previous exercises with the statistics. I'm going to go OK to the data. My list is in A, put the square brackets afterwards. I've not renamed it. The frequency is 1. The confidence level is 95%, so 0.95. And I'm going to ask for the results to be put into column B. So I'm going to press OK. And now I can see that I'm getting my confidence interval. My lower value is 27.91, and my upper value is 37.2857. So there we go, this value here. And that is all we need to do for confidence intervals. Let's just check on the book that they've got exactly the same thing. So they're putting, so this is just clicking through, obviously, from the calculator here. And I've chosen the TI Inspire version. So put in your information in the first column, choose data. We're going to a T interval, confidence interval. And they've renamed A X. I've just gone with A with square brackets. And there we go. Really dead simple. We are now making a prediction for the range within which the mean lies to 95% confidence. So we have 5% unconfidence. we're not confident by 5% that so with a 5% chance it could fall outside of that range. Now, obviously, it depends on n, depends on how close these are together, depends on the standard deviation that you have here, as to how spread out all of this is. If these values are really spread out, then you'd be imagining that the confidence interval will be much more spread out. If these are all really close to a central value, let's say 34 or something. So if these were all really close to 34, then you would be very confident that that the range would be much tighter around 34, for example. Okay, right. That's all you need to know for this one. So that's done.